Okay, let's dive in. Imagine looking at just a mountain of dead batteries, the kind that power our lives but then just become toxic junk, and figuring out how to turn that junk,
Yeah.
well, into clean fuel.
Yeah, not just getting rid of it, but
Totally.
actually using it to make energy.
Exactly. It sounds like something out of a fantasy novel, right? Like modern alchemy.
It absolutely does. And what's truly fascinating is that this isn't fantasy. It's a real scientific breakthrough happening right now.
Right. Or rather, it's a revolution emerging from Austria. Today, we're taking a deep dive into a process developed there that promises to transform used batteries into renewable methane.
Mm-hmm.
Our source material for this deep dive, which really lays out the details of this pretty groundbreaking idea, comes from Union Rayo.
And our mission today is to, well, really unpack this, to understand not just what they're doing, but how it works, the immense problem it tackles, and why it stands out as such a significant development, in the global push for sustainability.
And look, beyond just being incredibly cool general knowledge, this is seriously relevant stuff. If you're tracking global challenges like waste management, pollution, the search for clean energy.
Yeah, all the big ones.
Right. Topics vital for being well-informed, especially, and this is important for many listening, if you're preparing for exams like the UPSC, environment, science and tech, current affairs. This hits all those key areas.
It really does. It's a concrete case study in circular economy principles and advanced materials, science solving these really pressing environmental problems.
Okay, so let's start with the problem itself. Batteries. They're everywhere, right? Phones, cars, everything. But what happens when they die?
Well, as Union Rayo puts it, they become, quite literally, an environmental bomb. We generate millions upon millions every single year, and as they degrade, they start releasing toxic compounds.
And how do they degrade? I mean, what makes them so bad just sitting there in a dump?
Well, think about what's inside. You've got various chemicals, often heavy metals, corrosive stuff, electrolytes. When the casing breaks down, maybe just from age or getting crushed, these toxic substances just leach out. They seep into the soil, get into the groundwater. It's this sort of slow, insidious kind of pollution.
Right. So what are we actually doing with this huge growing pile of hazardous waste? Union Rayo's report outlines some, well, frankly, concerning current methods.
Yeah, globally, the approaches are generally pretty limited and flawed. One common method is partial recycling.
Which sounds okay on the surface.
It does, yeah, but the article highlights its big limitations. Partial recycling tends to focus only on getting out the most immediately valuable materials, things like nickel or cobalt.
Okay.
But batteries are incredibly complex inside. Separating everything out is difficult, it uses a ton of energy, and it's expensive. So you only recover a small fraction, and you're still left with a lot of less valuable, potentially hazardous stuff that still needs dealing with.
Okay, so partial recycling is inefficient, expensive. What else?
Accumulation, basically just storing them. Dedicated battery cemeteries, as the source calls them.
Just piling them up.
Pretty much. They just sit there because there isn't a really viable, large-scale solution for the bulk of the material. It's essentially just, kicking the can down the road.
And the worst case scenario, the really bad option.
Well, the report points to disposal in landfills, or even worse, exporting them to developing countries. That's flagged as the most problematic.
Not exporting.
In landfills, they cause the leaching we talked about, but exporting them often to countries that just don't have the facilities or regulations to handle hazardous waste safely, well, it just moves the environmental problem and the ethical burden somewhere else. It leads to significant contamination in those places.
Right. That's grim. So we have this critical growing problem of toxic battery waste, and our current solutions are either inefficient, costly, or actually harmful.
Exactly.
This is where the Austrian innovation comes in then, as a potential game changer.
Precisely. This new process, developed at the Technical University of Vienna, offers a radically different approach. And the brilliance, as Union Rayo points out, it isn't magic. It's just very clever science focused on resourcefulness.
Resourcefulness. How? What are they reusing?
So the key is reusing materials from the spent batteries themselves, not just, trying to pull out the few precious metals. Specifically, they're using nickel, which they might recover anyway, but also alumina.
Alumina, where does that come from?
From the aluminum foil components inside many batteries.
Ah, okay. So instead of that just being waste after maybe getting the nickel or cobalt, they're finding a use for that too.
Exactly. And they transform these waste materials, the nickel and the alumina, into something incredibly valuable. A special nanocatalyst.
A nanocatalyst. Okay, let's pause on that for a second. We hear catalyst in chemistry. right? It's something that speeds up a reaction. But nano, and one made from battery waste, what does this specific catalyst actually do?
Right, good points. Nano just refers to the incredibly small scale. We're talking particles measured in nanometers.
Hmm.
This tiny size gives the material a huge surface area for its volume, which is really important for making it effective as a catalyst.
Okay.
Now, this specific nanocatalyst made from the battery waste has a remarkable function.
Wow.
It converts COOR carbon dioxide, the big greenhouse gas, into methane
Using, what does it react to the CuO with?
using hydrogen. So the catalyst basically helps the reaction between CoOR's hydrogen happen efficiently, producing methane, which is CHO, and water, HO.
Okay, wow. Let me get this straight. They take materials from toxic battery waste, turn them into this ultrafine catalyst,
Yep.
and then use that catalyst to grab QRO, add hydrogen, and create methane.
Yeah.
And methane is basically natural gas, isn't it?
It is, effectively. The result is you're producing a clean, renewable fuel directly from materials that were previously hazardous waste, and you're using up carbon dioxide in the process. It completely flips the script on waste disposal and carbon capture. That's the modern alchemy Union Reo refers to.
So the waste isn't just treated or stored, it becomes an active, essential part of generating clean energy. That's a huge shift in thinking.
It really is. Instead of just managing a problem, you're actually leveraging it to create a solution to another massive problem, our need for sustainable energy and ways to deal with co-euro.
What kind of potential impact are we talking about here? What does Union Reo suggest this tech could do?
They really highlight that dual benefit.
Yeah.
It tackles the waste issue and turns it into an energy source. The potential uses could be vast. The technology could theoretically cover significant energy needs for industries, maybe even transportation, like powering cars eventually.
Energy for factories, for vehicles. Sourced from old batteries and co-euro. The scale of that, the potential environmental help, seems massive.
Absolutely. I mean, think about the environmental wins. You're directly reducing co-euro, a primary driver of global warming, by converting it into something useful. You're taking waste materials that would otherwise sit there leaching toxins and integrating them back into a productive cycle.
And the methane itself, it's a direct alternative to fossil fuels, to conventional natural gas.
Exactly. It can substitute for it, reducing our reliance on extracting and burning fossil fuels, which, causes its own pollution and emissions. So you're hitting multiple environmental targets at once: waste, carbon emissions, fossil fuel dependence.
Union Reo really frames this as a potential revolution, doesn't it, in electronic recycling and emission reduction for these key sectors. And they make a pretty bold claim about Austria's position globally because of this.
They do. The article suggests Austria could become a major reference point for sustainability worldwide, maybe even, as they put it, the queen of sustainable solutions. It's definitely a testament to the innovative thinking behind this.
And it's interesting how the source positions Austria's approach compared to other global tech hubs.
Yeah, it draws a contrast with, say, Silicon Valley, often seen as bragging about future inventions, or China, which dominates large-scale manufacturing.
And Austria's approach is?
Austria, according to Union Reo, is taking a different tack. They are, and I like this phrase, closing the circle by looking at what we already have and how to use it better.
Oh.
The article calls this a very interesting bet, and above all, revolutionary. It's more about optimizing and achieving circularity rather than just purely inventing brand new things or mass-producing existing ones.
That closing the circle idea feels really significant strategically. Instead of just focusing on getting maximum value from raw materials or making totally new ones, they're focusing on maximizing value and minimizing harm from materials that are already out there, or in this case, already in the waste stream.
Exactly. It shifts the innovation focus towards, resource management and creating value from secondary streams, which is going to be increasingly vital in a world where resources are getting tighter.
So let's bring it back to the listener. Why does knowing about this specifically matter to you listening right now? We talked about getting informed quickly and thoroughly, and this Austrian breakthrough seems like a perfect example of distilling a complex issue.
Yeah, understanding this tech gives you real insight into these cutting-edge solutions for global challenges that, frankly, affect everyone. It's valuable context for any discussion about the environment or policy debates.
And, as we flagged earlier, if you're specifically engaging with topics relevant to exams like the UPSC, this isn't just nice to know, it could be crucial.
Definitely. Think about the environment paper. This ticks boxes for waste management, pollution control, innovative recycling methods. For science and technology, it's a prime example of applied chemistry, catalyst design, green tech innovation.
Mm-hmm.
And in current affairs, it's a significant international development in sustainable energy and resource management. It shows how science translates into real-world solutions for policy-relevant problems.
Right, it's not abstract theory, it's happening. And it really prompts you, the listener, to think critically. How could something like this fit into, say, India's waste management strategies? What infrastructure would be needed? What are the regulatory hurdles?
It just opens up a different way of looking at how we tackle waste and energy together, doesn't it? Seeing waste as a potential resource, not just this awful liability.
So, wrapping up this deep dive then. Austria's process, as detailed by Union Rayo, offers a truly groundbreaking solution to this massive crisis of battery waste. By transforming materials from used batteries into a unique catalyst that converts CO into renewable methane. Well, they've basically forged a path to turn toxic liabilities into valuable energy assets.
Embodying that revolutionary approach to sustainable innovation, that closing the circle.
It's a really powerful demonstration of how looking at existing problems and existing resources in new ways can yield some truly transformative solutions. Now, considering the sheer scale of battery waste globally, it's enormous, and the urgent need we have for cleaner energy sources, here's a final thought to leave you with. Beyond the science, beyond the technical side, which seems amazing, what do you think are the biggest non-technical challenges? Things like economics, logistics, maybe politics, to actually implementing and scaling this kind of battery-to-methane technology worldwide?
That's a big question.
And how might international cooperation or maybe specific policy changes help overcome those hurdles? Something to mull over.
Yeah, it definitely touches on global infrastructure needs, investment, getting countries to work together on policy.
Remember, this deep dive into Austria's innovative process was based on the material provided by Union Rayo.
We really hope it's offered you a valuable perspective on this very exciting development.
Absolutely. And if you found this deep dive insightful and valuable, especially if you're tackling complex topics like these for UPSC preparation, or maybe you just want to stay ahead of the curve on sustainable tech, please do consider liking and subscribing.
Yeah, your engagement really helps us bring more deep dives like this to you.
And we'd love to hear your thoughts. Please comment below any questions you have, or if you are preparing for UPSC or similar exams, share how you see this specific technology fitting into broader exam topics or maybe potential essay questions. Let's keep exploring this fascinating future together.